Hello everyone and welcome to today's SPaT Challenge webinar on J2735 Map Creator Tool Demo. My name is Neelu Parvinashtiani and I will help facilitate today's webinar. Today's webinar is hosted by the National Operations Center of Excellence, NOCO, who offers resources to support the transportation systems management and operations community. If you look at your screen, on the bottom left side of the screen, you can see a useful link box where several links are shared with you. So the first link is NOCO's Knowledge Center that includes an entire collection of TISMO resources. So feel free to browse those resources through that link. Also, register and subscribe on our website for our bi-weekly newsletter and major TISMO announcements. I'll cover a few logistics before going through the agenda and our speakers today. So for this webinar and every webinar, we will be recording the webinar, and also we'll have the presentation slides ready to be sent to you in a post-webinar email within 1 to 2 days. You will have access to today's recording as a video and also all the previous SPaT Challenge webinars and all the other NOCO webinars through the on-demand learning section of our website. For today, we will have a question and answer session at the end of the webinar. So anytime during the webinar, if you have any questions, please put them in the question discussion pod, and at the very end we will read those questions out loud one at a time and ask our presenters to answer the questions. So to go over today's agenda quickly, and the presenters, first of all, I have asked the speakers to briefly introduce themselves before their presentation. So but the full bios of the presenters are shared with you through NOCO's webpage for this webinar. So please refer to those to learn more about our speakers today. So for today, first we will have Blaine Leonard from Utah DOT to do an introduction of the SPaT Challenge and this webinar series. Next, we'll have Kyle Rush from Leidos to go over a live technical demo of the J2735 map tool. And after Kyle's presentation and demo, we will cover Q&A, like I said. And in addition to Blaine and Kyle, we have a few other people who also from Leidos who also support to answer your questions. We have Meta, Janet from Leidos, we have Matt Marchese, and we have Leonid from Kenin, also from Leidos. So that is all I had to share with you, and I'll hand it over to Blaine to start us off with the webinar.
Thank you, Nilo. We appreciate you kicking us off today. And I want to welcome everyone who's joined the webinar today. We have over 100 participants, and we hope that we've got some good information for you. I'm assuming if you're here that most of you are familiar with what the SPaT Challenge is. We've challenged infrastructure owners and operators around the country to deploy ESRC to broadcast SPaT and, of course, map messages in at least a corridor network of 20 intersections in every state by 2020. The SPaT Challenge is just 2 years old. It was initiated 2 years ago in April. In that 2 years, as you can see on the map, we have about 35 locations in 25 states. Currently, there are about 500 RSUs operating at those locations marked in blue, which are complete, and about another 2,300 RSUs planned in the rest of those deployments. So we're pretty excited about everyone's efforts and enthusiasm in moving this forward, and we think this is a great endeavor. And of course, in the past week, there's been an announcement by a major automaker that they're going to put DSRC on all their models in the next few years, starting in 2021. So that will really help. We will now have some infrastructure that they can start to talk to and plan to talk to. So this is an exciting effort, and we appreciate everybody's involvement in this effort. This is the fourth in a series of 6 webinars. We started in March with a webinar which covered some general basics, talked about systems engineering and concept of operations, spent a little time on costs and procurement and how to select a corridor. Later in March, we had our second webinar, which was the first of 3 focusing on some design considerations. We talked a lot about the SPaT message and how to assemble it, what it looked like. Looked at the V2I Hub product that Federal Highway Administration has developed, and also talked a little bit about some experience some agencies have had with deploying onboard units, which isn't necessarily a direct part of the SPaT challenge, but a number of agencies have stepped onto the receiving end, which is a good thing. The second design consideration webinar, which is the third of the series, focused on map messages, and we looked at the map message as they're defined, looked at one specific example here in Utah of how we have created map messages, and then talked a little bit about vehicle position correction, or RTCM, correcting the GPS locations. Today's webinar is the fourth, and it's really an outgrowth, sort of an extrapolation, if you will, of the one last week, focused on map messages. Today's is a little unique in that it is looking very specifically at one tool and how to use it. It's a live demo of this tool, and we think that this will be useful to a lot of agencies as they create map messages. As we learned a week ago, creating the messages takes some effort and isn't a trivial function. So that's sort of what brought about today's webinar. As Nilo said, the past webinars are all archived, both in video and audio and the PowerPoint presentations. And if you go to the SPaT Challenge resource page on the National Operations Center of Excellence website, the address is shown here on the top of this slide. You can download and get access to these recorded webinars. I show a blue arrow where that's possible. You've probably been there because that's probably how you registered for today's webinar as well, and can register for the next couple. As always, if you and your agency or your client's agency is working on the SPaT Challenge and planning to deploy, we would certainly like to know that. If you could email this address here shown on the web page and give us the information shown that's bulleted here, so that we can put you on the map. We'd love to have everybody's activity on the map so that everyone knows that the rest of us are involved, and allows us to sort of show our progress and allows us to contact each other so we can help each other move through this. So please do that if you're involved. We have 2 more webinars coming up, one in a few weeks on May 15th, which is the third of the Design Considerations webinar. It'll actually be webinar number 5. And it's focused on backhaul infrastructure and intersection and roadside equipment specification, design and installation, and DSRC licensing. So as many of you know, the DSRC units, the roadside units, need to be registered, and we'll walk through that process. And finally, in June, we'll have a webinar that talks about how to validate the messages you're sending from the roadside and verify that they're actually being received. We'll talk a little bit about security and also some procurement issues. So we hope you will put those on your website, on your calendar, and join us for those. So with and here's a little more detail on that webinar. I think we'll come back to that. So with that, I'll turn it over to Kyle, who will lead us through the demonstration of the tool that they have developed. Kyle?
Cool. Thank you for the introductions, Nilu and Blaine. I'm going to start sharing my screen here in just a second, and then we'll start walking through the presentation. Okay. Cool. Oh, danced one too early. All right. So thanks for joining us all here today for this overview and walkthrough on the United States Department of Transportation's J2735 map message creation tool. So I'm going to start off with a brief overview of the contents of this presentation. We're going to do a quick look at the basic concept of a map message and its kind of structures to foster a common understanding of what we're talking about, as well as a little bit of information about the map tool itself. Then I plan to go through a walkthrough of the map tool user interface to kind of explain all of the different elements so that there's no surprises when you're interacting with it. And then I will do a live demonstration of creating a map message start to finish for one of the very simple intersections we have here at Turner. It should show the whole process from picking the location to ending with a full map message. And then I would like to kind of showcase the difference between that finalized map message and a much more complicated message that was built with the tool for an intersection in New York City. And then there's a walkthrough of the encoder tool that's built into the map tool we have, and a little bit of a showcase of the message validator tool to make sure that once you've got everything generated, that it is in fact valid before you go ahead and do anything with that message. So to begin getting into things, a little bit about me. My name is Kyle Rush. I'm a software developer for Leidos. I work on contract at the Saxon Transportation Operations Laboratory, or the STOL, for the Federal Highway Administration. A lot of my work here is in the connected automated vehicle space, dealing with map messages and other DSRC messages on the regular. So about the tool in particular, it's a USDOT funded tool and developed under a USDOT program. It facilitates the creation of SAE J2735 map messages via a web application interface, and it's currently available for use by any interested parties. You don't have to register for an account. There's no approval process, although we do recommend that you sign up for an account with our ticket support system so that you can submit any issues that you might encounter. And the tool is currently under development and enhancement at the STOL. Digging into map messages a bit, they describe the physical layout of an intersection or stretch of roadway in a digital form for broadcast by roadside units and consumption by vehicles or other data consumers. In this use case, we're primarily concerned about their intersection capabilities. So we'll be looking at things like lanes and stop bars, crosswalks, how these different movements in different lanes map to signal groups, and the different kinds of maneuvers that are allowed at each lane in the intersection. These lanes and other objects in the message are built out of point segments connected by straight lines, so we're not dealing with curves in this case or anything of that like. And they're used by connected vehicles and connected automated vehicles for safety critical and non-safety critical applications. And the messages we'll be dealing with are standardized by SAE J2735, specifically the 2016 revision of the standard. The map tool provides a simple web application user interface for the construction of these map messages by drawing the associated geometry onto satellite or hybrid imagery map tiles. So you get a pretty good visual view as you're building the map message that you want to be broadcasting. It allows for the configuration of all the various data fields associated with these lanes and specifies their units, their minimum max values, and has descriptions to help you figure out where you should be putting your data. It's able to generate the actual binary output for broadcast at a roadside unit with their store and repeat functionality. And the tool is available at the URL you see on the slide, and the support system is available at that URL as well. So here we'll dig a little bit into a brief overview of the map tool. You see a screenshot of that below this title slide, and I'll be walking through the major user interface elements and their roles and any of the modal dialogues that might pop up or whatnot, so that it is clear exactly how to operate the software. This is all a web application, so it's running in your web browser, but once you navigate to that URL, this is the interface that you would see. So starting kind of at the top and working our way around, up at the top left, we have the address search box, where you can type in the street address of any particular location you would like the map to zoom over to. So if you have a particular intersection in mind you're looking at creating a map message for, you can just enter that there, and it will find it for you. To the right of that, we have the options menus, your standard file tools kind of dialogues. That's where you'll find your save functionality, additional help menus if you want them, as well as the encoder and various other bits of functionality that I can get into a little bit later in this presentation. Slightly below that, we have the map layer toggles, which will control the visibility of different layers, such as road names, the hybrid imagery I was talking about earlier to show you map road lines instead of just the satellite imagery, and various other data elements that might be useful, but maybe not all the time. Below that, we have the zoom controls. You can use those to increase the level of detail to a certain point in the imagery you'll be seeing. You can also use the mouse scroll wheel to zoom in and out as well. They perform the same functionality. In the bottom left corner, we have the help button, which will pop up a helpful dialog that describes kind of a walkthrough, similar to what I'll be providing today in terms of general aim and content, that describes the flow of how one might use the application. And lastly, on this screen, just above that, we have the map tile info section, which will describe to you the date at which the satellite imagery for the tile was captured, as well as the current numerical zoom level. The zoom level, I believe, goes 1 through 20, anything in increasing order of how close it is. Anything below 17 is entirely new imagery at each level. 17 and above is simply extrapolated, so it's a little bit larger in case you really need to get in close, but it doesn't actually contain any more detail. And these map images are all sourced from Bing Maps, so if you have any sort of concerns about the latitude, longitude accuracy of that, that would be kind of your reference datum there. In the next screen, we're showing some of the dialogues that might pop up, as well as the toolbar. The builder on the left contains the elements you can drag and drop onto the map or onto other dialogues for the purpose of adding these elements. We don't need to worry too much about what the reference point marker and the verified point marker and so on are right now. We'll get into that a little bit later when we're actually building a map message. But for now, that is where those elements will come from. The additional dialogue is where you'll be entering some of the data elements the map message is going to require you to provide. You'll see it's asking here for latitude, longitude, and whatnot. And it provides in the form of those question mark buttons helpful little pop-up dialogues describing the units, their ranges, etc., for all the different values that you might need to enter. And then at the bottom left here, we have the toolbar, which is going to contain different elements depending on what kind of mode you're in, what you're doing with the application. But fundamentally, it's where you're going to be accessing your various tools, be it to draw lanes or be it to, delete elements or edit elements, so on and so forth. And that blue icon all the way at the left of the toolbar is what you're going to use to pop up this builder that we see here. So if I go on to the next slide, we have the lane design tools, which will show up when we're in the process of editing and creating lanes and approaches. There's the boxes for approach editing, one for creation, one for editing, lanes, one for creation, one for editing, and then a handy measurement tool in case you have any questions about the length of certain elements or the distance between different elements in your map message. You can use that to verify and check to make sure that everything's as you expected it to be. So that said, we'll now kind of get into the walkthrough of the map creation itself. I'm going to navigate to that link you see below and begin developing the Turner-Fairbanks map message for our west intersection. So hopefully this works. If I tab over, this is the landing page for our Connected Vehicle Services website. This ISD message creator is the particular tool we're going to be using today. ISD in this case is intersection situation data. It's a combination of hybrid map and SPaT for use at the safety pilot, but it is fully supported for development of just map messages, as we'll be demoing here. So I'm going to click View Tool to navigate to this page. And then up at this address box, I'm going to type in the address for our facility here at Turner-Fairbanks, and here it pops up. And you can see it zoomed right to our facility. I'm going to zoom in by clicking the zoom icon a couple times. And here we are zoomed in, and I'll go ahead and start creating the map message. The first thing we're going to do is we're going to create what we call in our system the parent map. And we're going to do that by going to File, New Parent Map. And now we're in the parent map editing mode, as you can see by this parent map up at the top. The parent map is going to enable us to share data between several child maps if that's needed for the purposes of splitting up a map message to size or building several adjacent map messages that might maybe share a common reference datum or a geographic correction or something like that. So we can enter this data once and then share it between multiple child maps. So we'll go ahead and get this set up. We'll go down here to click the Builder tool. And the first thing we're going to do is we're going to drop our reference point marker approximately in the center of our intersection. Normally, one might take some time to be pretty precise with some of these things, but for the purposes of expediency for today's demo, I'm not going to worry too much about exact positions and whatnot, just so we can make our time constraints. But we are going to just place this here. The intersection ID is automatically generated. All of these values are taken directly from the Bing map tiles, and I'm just going to enter a name for it, and then I'm going to say that it is a signalized intersection. Now, if we wanted to know more about this particular detail element, we could click this question mark icon here, and it'll pop up this dialog that shows us a little bit more about that particular element from the standard. So in this case, we've just entered the name, and now we're going to click Done now that we're done editing this particular element. So that's in the center of our intersection. And then we're going to take this verified point marker, and we're going to place this verified point marker at some visible location on the map that we can see that has a known GPS coordinate, either from survey data or from high-resolution mapping or anything of that kind. And we'll be using this particular point to perform corrections between all the other points in the map message and this known point. So hopefully we can mitigate some of any of the error that might have crept in during the satellite mapping or the projection conversion and whatnot. Since we don't have that survey data offhand for this, I'm going to not edit these columns, but you could fill in these with your survey data, this verified latitude and verified longitude, as well as verified elevation, and that will perform that correction at map message encoding time. So we'll just click Done here. And that is all the elements we need to add to our parent map. This is the data that is shared between the children. It's the center of the intersection, our reference point, and the known good verified latitude and longitude coordinates. So with this done, we're going to click File, Save. We're going to enter a revision number. This is our first revision, so we're going to hit 0. And I'm going to click Continue. And now it pops up a Do I want to save dialog, so I'm going to say yes. And then we're going to move on to creating our child map using this data. We'll do that by going to File, New Child Map. We've already saved it, so we're good to continue and delete any progress. So then we will follow the instructions to open the parent map that we just created, which should be under my downloads. Here we go. So now we can see we're in the child map editing mode. But you can see it's imported all of the data from the parent that we just entered. This data is not editable from the child's perspective, so it's locked. You're guaranteed consistency between all the children of the same parent map message. But we can still see it here for our reference and usage. So now that we're in the child map editing functionality, the first thing we're going to do is we're going to draw in all of our lanes and crosswalks, all of the geometry that we need to represent this map. Again, I'm not going to try to be too terribly precise here, but we'll make sure that everything's at least close enough. We try to draw from the stop bar down the center of the lane to about 1,000 feet away from the intersection is currently our practice. You click the lane tool down at the bottom left, which you can now see is green, and then wherever you want your lane to start, you click, and then you continue to click at all the additional points in the lane that you want the lane to continue to. When you're done with the lane, when you finish marking all of the space that you need it to take up, you double-click, and now you can see that that lane is colored in orange, and it has all of the points we inserted clearly marked. So I'll go ahead and do this for all of the lanes we have here. For the egress lanes, we like to mark from the stop bar. From the ingress lanes, we like to mark from the stop bar. From the egress lanes, we like to mark from the edge of the crosswalk associated with that lane. So now we have a second lane and a third lane. And then I'm just going to continue going around the intersection, adding as many points as I need to try and keep the line of the lane as close to the middle as my application might need. I'm going to continue marking here. And at any point in this process, if I make a mistake that I'm not too happy with, like let's say this particular point is a little bit too close to the other lane, I can go down to this Edit Lanes button here in the Lanes category, and I can start to click on these points, and I can move them around, or I can add new points in the middle of a lane, and so on and so forth. If I need to add additional precision or anything like that, I can always go back and edit these to match more closely to what I was hoping. And then when I'm done making my edits, I can click out of that Edit Lanes box, and we're back in normal mode. So then I can resume drawing lanes. And I'm just going to try and model this corner so that it stays about as close as it can, a little bit off. So for this particular one, this is one lane in the real world, but here I'm going to draw it as two lanes just to showcase some other features a little bit later. So I'm going to attempt to draw those in. And if we're a little bit off for the purpose of this, it's added one too many points. It doesn't matter too much. There we go. If we want to clean that up a little bit with the Edit tool, that's better. And then I'll just draw in the second lane for that particular approach. We're getting a little bit off here. Generally, our best attempt is to make sure that the lines never cross over the road edge. We're off here for the purpose of speed, but that would be our best recommendation. They should never cross the edge of the lane they're attempting to mark or the road edge. And finally, for this last lane here, this last vehicle lane we're going to mark, I'm just going to draw that in to about there. So we have all our vehicle lanes marked now, but we should also demarcate all the crosswalks that are in our particular intersection. So I'm going to start at this crosswalk and just pick a direction and mark them all. And we will set all of the data elements on all of these lanes later once we have them all drawn, but it's important to get our geometry marked down so that we're happy with the structure of everything before we get too attached to any of the particular elements. So now we have all of our lanes, oh, missed one. Now that we have all of our lanes drawn in, we're going to go ahead and start drawing in the approaches. These approaches are just groups of lanes drawn with this Draw Approach tool over here that correspond to sets of ingress or egress lanes in the map message. So we start by, if we accidentally add a point like that, you can click this Delete tool down here in the toolbar and come up here and just click on the element you want to get rid of, and then it's gone from your geometry. So now that we're back in the Approach tool, I'm going to draw in a box around each approach like this. It's important that you only need to get just the head of the lane that you're trying to demarcate as that approach. You have to get the very point that you started drawing the lane from, whichever direction that is. So now that we have a box there, we can refine it a little bit with this Edit Approaches tool. So I'm going to click on this approach, select it, and then we can either move the center point by clicking the center red dot, or we can resize and rotate that by clicking the corner red dot. So I'm going to get that approximately aligned so it still holds the point I was looking for, and then I'm going to click out of the approach tool and move on to the other elements that I am trying to insert. And we'll just draw in one for every lane. I'm not going to worry about rotating the rest of them since there's only one lane at each approach, except for that bottom lane, which I will get to. But in a normal use case, if you have multiple lanes in any given approach, you would want to make sure that they're all grouped appropriately. And for this one, I will draw a box large enough and make sure to rotate it to fit. And there we go. Now we have all of our approaches. Oh, -1. Now we have all of our approaches drawn in. So that's all the geometry we'll need to mark for this simple intersection. We have the verified point, we have the reference point from the parent message, we have all of our vehicle lanes, we have all of our crosswalk lanes, and we now have all of our approaches filled in. The next step from here is for us to begin filling out the data elements we need to assign values to all of these geometric objects. But first, we're going to go ahead and make sure to save our work. So we're going to come up here to this Files menu, and we're just going to click Save. It's going to ask us for a revision number. In this case, this is our first one, so we'll call it revision 0. We're just going to click Continue, and then we're going to save this GeoJSON file that contains our intersection ID and the child indicator. Now that we've saved our map message, if we ever wanted to load the same map message, we would go to Open Child Map. We would browse to that very same file we just downloaded. Child, here we go. And now we're back where we were. So we haven't lost any work. We want to make sure to do this frequently so that if we need to make any edits or if we need to go back to the previous version, we can do so. Now that we've got our geometry, let's start filling in the data we need. All of these items need to be assigned IDs, they need to be indexed, we need to configure them for whether or not they're egress or ingress lanes, so on and so forth. So we'll start from the bottom and work our way around, just assigning information to all of these lanes. We'll start with the vehicle lanes, and to configure this, we start by clicking the front node of the particular lane, the lane we started, or the node we started drawing that lane from, and that'll pop up this lane configuration dialog box. We can configure the lane attributes if there are any particular attributes we would like to set. We can configure the lane type, what it's shared with, its number, and the latitude and longitude of the initial node, as well as how much the lane changes width from the reference node. So we'll set this as a vehicle lane type. In this particular configuration, we're not going to say it's shared with anything, although we have plenty of options that we could combine it with if we wanted to. Same with the shared width options. And our lane number, we'll just select lane 1 for this first node we're going to configure. We'll get to some of these other tabs in this dialog later when we've finished configuring the rest of these other nodes, the rest of these other lanes, sorry. But for now, that's all that we needed to set for this particular lane. So now you see that this lane is numbered lane 1 in the diagram, and that shows on all the points in that lane. So we're just going to repeat this process going around for all of the other vehicle lanes in our system. And you can see that when we go to select lane number lane ID 1 is no longer available as it's already been selected, so we can't misconfigure it in any way. We just can pick the next one and continue our way around the intersection. So we're going to repeat this process for all of our lanes here until we have them all marked. Then, once we have all these vehicle lanes marked, we can begin to configure the approaches and the pedestrian crosswalks in this intersection as well. Working around our configuration. Okay, so now we have all of our lanes, number 1 through 9, configured with their lane type as vehicle lanes, and we've given them all lane numbers. So the next thing we can do is we can begin to go ahead and do the same for our crosswalks. If you ever click on the non-first node of a lane, you'll begin to see this screen. That's just editing that particular point. All you have to do to get the right one is to click Done and just select the other end, which holds all of the data. In this case, we have a crosswalk, so we're going to select the crosswalk type. We could, again, select any number of type attributes for our crosswalk should we want to configure them. These are all defined here with descriptions. Same with shared width. We can do any of those. But for this case, we'll just give it a lane number and keep moving around our intersection. All right. Now, all of our lanes are numbered, numbers 1 through 13. We have them configured as vehicle or crosswalk types. And the only thing that remains to configure as far as numbers go are the approaches. So I'm going to, in a similar fashion, walk all of these and configure all the approaches. When you click an approach box, it's going to ask you for the type, whether it's ingress or egress. And it's also going to ask you for an ID. The approach IDs are separate from lane IDs, so we don't need to worry about deconflicting those. But they'll follow a similar pattern where we can't select previously used ones, so we won't run into any potential conflict issues. So we'll just begin to mark these all the way around as well. So this will be an ingress approach and approach ID 1. And then we'll just keep numbering our way around. This is an egress lane, and it will be 2. In this case, these approaches all have 1 lane in them, but that is not necessarily the case for the tool. As you can see in the bottom, we have one with 2, but you could have any number of lanes in a given approach. So that's something the tool is capable of handling with ease. All right, and here's our last approach to configure, number 9. Number 8. Okay, so now we have all of the basic data elements for all of our lanes, crosswalks, and approaches filled out. They're all numbered, they all have types. So this would be a good starting point now. We can begin to define how these lanes and crosswalks interact. Part of the standard enables us to use these connections or lane attributes tags to specify what maneuvers vehicles are allowed to perform at any given lane in our network here. You can do it either way. Both are valid. It depends more on your particular application and use case that you'll be using. And I'll show both for this one and then continue with the connections style. In this case, you would click the builder down here to bring up the options to drag on to your lane attributes field over here. So for lane number 1, which we're editing, you can go straight, and we'll just drop that over here. You can make a left turn. So that would be sufficient in this case. We can also set this information in a more granular way under the Connections tab. This allows us to specify lane-to-lane connection through the intersection. So in this case, we could say that lane 1 connects to lane 7 under a signal group ID, which will be determined by your particular traffic signal controller configuration. In this case, we'll just number it 1 for our sake. And then that would be performed with a left turn maneuver. We can delete these configurations if we want by clicking this trash can, or we can add more to continue adding granularity to our connections here. So it could also traverse over to lane 5, and that would be under a signal group ID. We'll number that 2 here, just for simplicity's sake. And that would be continuing straight. And now this lane is marked as connected to both lane 1 and lane 5. So if I click Done here, and then I close this out, we can see under, if we highlight this, it now shows connecting lines to those particular lanes. So if we continue around the map, we can keep filling all this in using the connections. So we'll say that this can connect to lane 5 under signal group 2. And then that would be continuing straight. And then this would also be able to connect to to lane 3 under signal group 2 with a right turn maneuver. And if we now click, after dismissing that, if we now click this, we can see those connections. So we'll just go ahead and fill these in for all the various connections in the map message. This would be continuing straight to lane 8. And then we could make a left turn into lane 9. And a right turn into lane 5. So we configure this on a lane-by-lane basis, just going around, making sure we have all of our data configured. Four can make a right turn to lane 5. Whoops, to lane 5. It can continue straight to lane 7. Or it could make a left turn to lane 9. The signal group IDs are going to be configured again based on whatever the configuration of your traffic signal controller might be. Whichever one corresponds to allowing these particular maneuvers is going to want to be the signal group ID you use in your setup. We're going to want to primarily configure these for the ingress lanes in our network. So we'll skip 5 and go to 6. And at 6, we can go straight to lane 9. And we can turn right to lane 7. 4 since it's a separate approach. But again, it depends on your configuration. And you could make a left turn to lane 3. And then at lane 8, we'll just do the same thing. Make a right turn to lane 9. We'll make a keep straight to lane 3. And we will add one for lane 5 as a left turn. That one we already configured. That one we already configured. Oh, that's an egress lane that was configured, so I'll go ahead and just delete these. And then it looks like all of our connects to are configured. All right, so now that data is all complete. Oh, we missed a lane. My apologies. Missed the mid-block crossing over here. We'll mark that as a crosswalk, and we will number it now as number 14. All right, so now that we have all of that data elements configured, that's all we have for the data we need for our map message. If we go ahead and we save this, we'll call this revision 1, now that it's more complete. And then that is our complete and our completely configured map message. So I'm hopefully going to be able to switch back to my slide deck for a second to recap. There we go. So, in summary of the map message creation process, the first thing to do is to create a parent map message. You're going to put the reference point at the center of your intersection, the verified point at a known accurate location nearby, and then configure the intersection data for your intersection, the name, the speed limits, any other data elements that you might want to make sure are preserved in that parent map message. Then you're going to save that file to somewhere easy to access on your computer. The second step is to create your child map message. You're going to load the parent map message that you created in part 1. You're going to want to draw in your geometry, your vehicle lanes, group those lanes into approaches, and draw in your crosswalks. Then you're going to want to fill in your vehicle lane details, your approach details, and your crosswalk details. Then configure the connects to values for your signal groupings and your vehicle lanes and all of the legal maneuvers at each lane. And then, now that you've entered all the data, just make sure to save that GeoJSON file to your computer for usage later or for later reference. With that summary complete, I'd like to show a more sophisticated example of the kinds of maps you can create with our map tool. The Turner-Fairbanks intersection I just showed is a relatively simple intersection, having only 8 real lanes and 9 lanes in that particular matchup, in that particular mock-up. But there's an intersection from New York I'd like to share, and I will switch back to the web browser to load that up. So if I navigate back to this file menu up here, and I go to Open Child Map, I'll browse over to the particular map message I'd like to show. This map message is when these tiles decide to load. There we go. One of the more complicated map messages I've seen built with our tool. It's in New York City at the intersection of Tillery and Flatbush. If I turn on the hybrid view, we can see the street names and whatnot. This particular map message pushes the size limit of the message standard with its intense number of lanes. I believe it has over 55, possibly up to 60, off the top of my head. It, in terms of its complexity and size, definitely is up there. You can see that it has many lanes grouped into approaches. It has divergent lanes for different flows of traffic. It's got all of the crosswalks mapped in. It's even got some of the side roads mapped in because they're relevant to this particular intersection. It's got more diverging lanes down at this bottom corner here. There's a lot of detail packed into this particular map message that makes it a challenge to develop, but it shows kind of the depth of what the tool can support, that if it can build an intersection as complicated in this and correctly encode it and make sure that it is represented correctly, then it's got some sufficient capabilities to build a lot of different map messages. This being shown, I would like to now do a brief demo of the map tool's encoding functionality. If I hop back to my slideshow for a second, just to introduce the next title. Getting back to this particular map tool, or this particular map message configuration we have here, I can go to the Tools option, and one of the options is to delete everything, but the other is to access the encoder system. If I click this Encoding Menu, we'll get a handy dialog that shows us kind of the current contents of our map message, the various data we have in it. And we'll get an empty SPaT message due to the way the system interacts with the ISD message mentioned previously. But since we're only worried about encoding map messages today, we don't have to pay any mind to this particular warning. So here we'll see the raw kind of logical data of the map message as we have it now. And when we finish our encoding, we'll get the abstract syntax notation version 1 encoding as a logical format there. And in this particular text box, we'll get the unaligned packed encoded hex values that we can use to upload to a roadside unit for broadcast. That will be the data you directly want to use over the air. On this screen, we have a couple of options. We can select the message type, and we can select the node offsets. For our message type, we have a couple of possible choices. We have the ISD message. We have the raw map contents, not suitable for broadcast, but if you wanted to do some analysis on it, it would contain less data. The message frame plus map object, which is what we are going to recommend we use. It is the J2735 full message ready for broadcast. And if we had included any sort of SPaT sample data with our map message, we could generate the SPaT message, the frame plus SPaT, which is the analog of the frame plus map, and the SPaT record portion of the ISD message. For this particular case, as mentioned, we're going to select frame plus map because it is what is available for ready broadcast over the air. The node offsets describe the relationship between all of the points in a lane. In the explicit encoding, we're going to be using full detail latitude, longitude points for every point in each lane. All of our reference points that we inserted will be expressed in their highest possible detail, which is going to produce a quite large map message, but may prove useful if you need the data to be more human readable or easy to consume for debugging purposes. Standard is similar, although lower resolution. It's a compromise. And then compact and tight refer to offset-based encoding methodologies, where rather than representing each point as their full latitude-longitude value, they represent them as offsets from the reference point in your intersection. Compact is going to use the smallest offset size that will work for all of your points. So it'll pick one particular offset size that it can use comfortably to fit every offset that it needs to fit in your message, and then use that globally. The tight encoding will select that value optimized at every point in your map message. So it's going to produce you the smallest encoding that we can do. And I'm going to recommend using the tight encoding for all of your uses, simply because it produces the smallest possible message. So we'll select the tight encoding, and then with that all set, we can go ahead and click Encode, and now we see that these two text boxes are full of the data that we just used, or that we just mentioned. So this is going to be the ASN1 data, the logical, human-readable, structured data. And then this contains that Uber-encoded hex data that you could copy and paste and upload straight to your roadside unit for use with its store and repeat broadcast mode. We've done this several times here at the Stoll, and it seems to work out pretty well for us. So with that encoding done, you can simply reach into this text box, select everything, and copy and paste that out into whatever other tool you would like to use to load that to your RSU. It might be a different upload mechanism depending on the manufacturer or vendor of RSU, but they should all support functionality to load these Uber-encoded messages. That concludes the demonstration of the encoder. I have one last tool that I would like to show off on the ISD, or on the Connected Vehicle Service website, that kind of goes hand in hand with the encoder, which is the message validator. So I'm going to copy all of this binary data out of the encoder, and then I'm going to navigate away from the ISD/map tool and back to the home page. And if you scroll down on the home page, you'll see this message validator section. So if you click View Tool, it'll take you to the message validator, and here's where you can paste or upload DSRC message for validation to see, make sure that your encoding processed correctly, or if you have some other parser you're attempting to use to make sure that you both arrive at the same result in kind of the expected fashion. So we're going to validate our map message by coming up here to message type and selecting message frame, since that's the base J2735 message we'll be using. And then we're just going to paste our encoded map message right into this text box. And once that's done, all that's left to do is to click Validate, and now we can see this parsed and validated message. So it turned green to show that our message validation was successful. It prints the particular type of message it was referenced as, or recognized as, in this case, a message frame object. And inside that message frame object, we can see the map data that we just asked it to encode. And this output here should be the same as the ASN.1 output we saw in the previous step with the encoder. Now, in the case that this hadn't worked, for example, say we malform our map message by deleting several bytes in it, and then we click Validate, you're going to get an error message explaining why the parse failed, and it's going to turn red to show that the message was not detected as valid. So that concludes my demonstration of the message validator, and I will jump back to my presentation for a quick second, just to give a brief summary of the encoder and validator. So there's lots to take in on this slide, but it's mostly what I had previously explained. The different message types, ISD being used by the Safety Pilot Program primarily to unify SPaT and map. The map message, map plus frame, SPaT, and SPaT plus frame. And we recommend, as is bolded here, the map plus frame encoding for your production needs. And then when it comes to node offsets, the explicit, standard, compact, and tight encodings. And we just recommend using the tight encoding simply for size efficiency of your message. It's going to be easier for your over-the-air broadcasts. And that largely brings us to the end of the this portion of the presentation. We've got some contact information here for both myself and Deborah Curtis, the Government Task Manager associated with this particular effort. And below you'll see the contact information for the Connected Vehicle Support Services, our toll-free hotline, and our web-based ticket support system. If you have any issues, please feel free to reach out to those resources, or any questions or concerns or enhancement requests, please do let us know. We're monitoring those very closely. And before I hand this off to Q&A, I would like to very quickly walk through just the user interface for that ticket system. Here's a screenshot from that web service. So if you have any particular needs or service requests or questions, you'll see at the top right there's a red box around the new service request field. Please feel free to follow that link and enter any information that you might feel is relevant there. And down at the bottom, you'll see under Useful Articles, map/TIM tool documentation. Now the TIM tool is not something we've covered here today, but there is documentation under there for the map tool as well. And if you're interested in the TIM tool, that may be of interest for you to read as well. So I'm going to leave this slide up for a bit, I guess, while we go to Q&A, but I think that concludes my section of the presentation.
So as far as the Q&A goes, I was going through everybody's questions as they were coming in, trying to answer them. This is Matt Marchese, by the way. But Kyle, I just have a couple of questions I think kind of consolidated down that you might be able to answer for us. The first one being just about kind of level of accuracy, distance between nodes, how finite do you need to make it, and then also what is our max data size and what is kind of the balance between number of nodes and data size, file size?
Yeah. As far as accuracy goes and how many points you have to place to model a particular lane, in reality that's probably going to depend on the particular application in usage. Our recommendation in a general sense is to use points to try and keep the line you're drawing in the center of your lane, but at the minimum you should never have the line you're drawing cross outside that lane. So it should always be inside the lane. As far as the trade-offs there with message size and whatnot, it's going to depend on the type of encoding you choose. It's going to be a larger cost if you choose the amount of nodes you have is going to be a larger cost under standard or compact encoding compared to something like tight encoding, especially if they're very close together. But there is kind of an upper limit on the size of DSRC messages around the 1400 byte range. That particular New York City map message that I showed was somewhere in the realm of 11 to 1200 bytes, with just all those lanes being filled in. So it's going to be just a trade-off of how accurate your application requires your map message to be versus how much space you have remaining in the message.
Okay. And one of the first questions that we got was kind of in reference to the parent and child maps. I kind of touched on this a little bit, but can you provide like an example when you might have multiple child maps to a parent?
One potential use case that I believe we considered in designing that functionality was if your map message is, if you're at or approaching that 1400 byte limit I described, that ballpark, it may be worth considering splitting your map message up into multiple map messages. If you have 4 approaches to your intersection, it might be worth using one parent map shared between 2 child maps, wherein you map the north and east approach on one child map and the south and west approach on the other child map and broadcast them separately. Or if you have intersections that are close enough that they can share a reference point and a validation point, then it might be worth using in that case as well. Those are some kind of the use cases we considered for that.
And I'll kind of a follow-up question. So you mentioned intersections being close to each other. We had one question regarding, is there any concern for if the maps overlay with or overlap with each other?
It's going to depend, I think, primarily on the application in play. I don't think there's a problem from a standards perspective or from a message perspective. But whatever, it's up to the application that's receiving these messages to be able to decipher and determine that it cares more about being on the egress or ingress for one intersection than it does about being on the ingress for another intersection, or whatever the case might be for the particular connected vehicle application at hand.
Okay, sounds good. Let's see, we had another one that should be an easy question. Should the signal group ID be in the phase number?
I believe they're related. The DSRC standard specifies the signal group ID as just an index, that it's not a particularly meaningful real-world value. It just corresponds to a state of a signal controller. So it doesn't necessarily have to correspond to a phase ID, but it would make sense to configure it as such.
Okay. And we had a couple of people ask if we could provide a GeoJSON sample for download. That's something that we could do.
Yeah, absolutely. I can look into however we need to distribute either today's sample Turner-Fairbanks map or the New York City map, and a couple others I might be able to send out as well if they're useful reference material.
Then they had one question, kind of comment, that mapping seems to be an excellent candidate for contraction out to consultant surveyors. Has anybody developed any specs or model specs for model RFP or this activity? Leonid, I don't know if you're connected right now, but feel free to chime in on any of these questions.
Yeah, I actually am connected. The specification basically is J2735, right? So it already exists. The JSON file is a GeoJSON format for open layers 2.0. So that is kind of defined. I'm not sure what. In fact, we do know some people who are using contractors for doing their mapping for them. They just basically, in their RFP, they basically said, we require that our contractors use this tool to generate messages, and kind of left it at that. I'm not sure if you're looking at more detailed, requirements around it. The idea, the original intent behind the tools was, in addition to creating messages easier, was also to provide some kind of enforcement, not so much enforcement, but agreement on how messages should be created. For example, the way we number messages, number lanes, and the way approaches are numbered, and so on, where you put a reference point. None of that is actually required by the standard. You can number your lanes any way you want, and they don't have to be contiguous or anything. But this was kind of to encourage people to follow the same process. I also wanted to mention, add to Kyle's previous answer about parent-child, that some intersections have different mapping depending on the time of the day. So some people decide that it's more convenient to create, because the lane's being used in opposite direction and so on and so forth. So they choose to create different maps for different time of day and broadcast those separately. That would be another scenario. And one of the complaints we had about parent-child is that once you created your parent, in the current version of the tool, there is no way to modify the parent and have the children to pick up that information. Maybe somebody did adjustments on site, did some measurements and wanted to adjust something. So we are releasing a new version next week that will allow you to modify parent and apply those changes to the children nodes.
Okay, thanks, Leonid.
And Leonid, you might be able to answer this question also. So there was some concerns with just kind of the resolution, particularly when you get in past 17 zoom. Is there any investigation done to use other image providers, such as Google Maps or ESRI image servers?
Yeah, we did some research. We're currently using Bing Maps, and originally we started with Google Maps, but we could not get that to work properly because they changed projection based on your zoom level. So maybe your zoom level is 12 through 15, use one projection. Then you switch to 17, it's a different projection. So what happens is that as you start zooming, your lines and your nodes are starting moving away from their original location. And we were not able to overcome that. So we started using Bing, and they don't have that issue. So that's why you can see that you're zooming in and out, and your picture stays steady on the screen. We are using a free package with it. There are probably better maps available from other sources, but we are currently not using or planning to use any other sources, at least with this version of the tool. If you know of some sources that are accessible, maybe not even free ones, that provide you with a better resolution, please open a ticket on the support side and put a request in there, and we'll check it out and look into feasibility of implementing that using some other map sources. But for the most part, for now at least, we're sticking with these guys. And I also see another question about importing a binary encoded U-pair message and getting a map out of it. We do have a feature request related to that, and we have it on our roadmap. It's probably going to be at least maybe a month or two until we get to it, probably more likely 2. But we do have requests of being able to import message that you just have from other sources and generate a GeoJSON map for it. One more thing I wanted to mention, that there was a question about how many nodes do you have, how far they should be apart. How far they should be apart is basically defined in the standard, right? So as because you have to use different type of encoding as you put them apart. So for example, if you want to put 2 nodes too far apart, you may not have enough value in the encoding field to represent that. So you may be forced to create additional ones. But there is more important side of it, and some of the users use kind of different philosophy about this, and they come from the requirement of how far the last node should be from the intersection, because it's a different way to look at it. And some recommend that, for example, it should be far enough, say 300 feet or more, just so you have enough time to stop the vehicle as you are approaching, right? Because they're kind of looking at it this way, and so they recommend to go out, say, depending on the speed limit again for that intersection, they may go out as far as 300 feet. Some others don't do that, like for example New York, some of those intersections are so close back to each other and so straight that they choose not to do that. So it's another way to look at it, and that may be driving how many nodes you need to put and how far away from the intersection they should go. That's it.
Let's see. And we have one question about the encoder. So is there a guide to interpret the error messages generated by the encoder? For example, if I got a ASN.1 error, approach 0, continue driving lanes.
Yeah, so those are, when you build messages using the tool, you're not going to have, you're talking, sorry, I misunderstood. You're talking about the map encoder error messages.
Correct.
Not validation messages. Okay, gotcha. So I don't know. I was not on the webinar the whole time. Did you, Kyle, show the error messages, that error icon that shows up when you have an error message, when you have an error?
I did not walk through that bit of the encoder.
Okay, because that is part of that answer. Basically, I saw somebody ask that question. I think there was a question I get an ASN1 error. Approach 0 contains no driving lanes, for example. This is one of those examples. So again, it's not required by 2016 standard anymore, but the tool requires that all the lanes begin at the approach. So node 0 should be inside that approach box that you created. And this error basically shows that you have an approach that doesn't have any lanes. And that's probably, you may see, it may look like you have lanes, but they may be starting outside. But what happens more often than that is that the tool is relatively sensitive, unfortunately. I mean, it's a browser kind of thing, right? So if you like selected your approach icon, right, and you accidentally like double-clicked or clicked with a tiny offset, you may not even notice it on the map, but there will be like a tiny approach that you just created. And you cannot really see it because maybe you already drew another approach on top of it, and so on and so forth. So when the encoder has an error, it places, in addition to the message, it also places a special icon on the screen that shows you that you have, let's say, approach without nodes or a lane that starts on the approach. And I don't know if you, maybe we can go back to the tool really quick and make an intentional error, because very often people spend a lot of time creating those drawings, and then all of a sudden it tells you that you have some node somewhere on the picture and you can't even find it. So that was added relatively recently, some maybe 6 months ago or so, to allow people to see where exactly the error is, because it may be you will seeing it, you may not still see it, but it will be underneath of it. Like maybe you will see a lane that covers another lane, and if you move it aside, then you will see which element is actually in error state.
Thanks for that, Leonid. Yeah, I think I see one of the questions in the question pod about the production suitability of the messages or the structure of the map tool. To my knowledge, I believe that New York City, as part of their CV Pilots deployment program, has, within the last, since their program started, built hundreds of the map messages. I believe all of their map messages, but I could be mistaken on that front. But at the very least, hundreds of their production map messages using this tool. The message that I showed today with the 55 plus lanes is a direct result of that particular effort. So the tool certainly has the capability to generate very complex messages in efficiently encoded formats. So from that perspective, it seems to be production suitable, at least for the New York City CV pilot deployment.
All right, and it looks like we just kind of have one other question about just kind of a summary of experiences on how kind of calibration or verification of these maps are after we've created them and tested them in the real world.
That I don't have a ton of data on. Leonid, do you have any particular stories from people? I believe Wolfgang from the Tampa CV pilot deployment had some things to say at one point in time, but I can't remember if that feedback ever got back to us.
Yeah, so the problem is, to a degree, is the quality of the map tiles that you are getting. So we do provide that verification point that you can use to kind of mitigate those errors. So those map tiles are not perfect, and the quality seem to vary across the country. So some rural areas may have lower quality maps, and some major cities seem to be more accurate. But it's it's kind of hit and miss to a degree. And Wolfgang from Siemens, they're doing Tampa, so they're not happy with the maps that they're getting there, although New York seemed to be okay. So Tampa used to complain that some of those tiles are so inaccurate that even one verification point is not enough and they're actually the ones who tend to create pretty long lane definitions, like those 300 feet that I mentioned before. So they notice that sometimes if you have inaccurate tiles and you go pretty far away out of the intersection, then they get significant error accumulating. So even a single verified point cannot mitigate enough for that. But it sounds like it depends on what your expectations are and the region you are mapping and how far your lane definition is, because that error accumulates with every node pretty much.
Thanks.
I wanted to also check maybe a few questions from earlier on. I know some of them overlap. I just want to make sure we don't miss them. So if it's already answered, just let me know. So one question is, I recognize that the map creation steps are truncated in the interest of time for this presentation, but I want to get a sense of the importance of the accuracy and the steps to attain that accuracy.
So to get the best accuracy you can out of the map tool, you're going to want to spend some more time than I was able to today kind of planning exactly how many points you want along your lane and kind of figuring out how many points you want for especially the curved sections, and then take a bit more time steadily drawing those in. As I mentioned, in the interest of time today, I was just kind of painting with broad brushstrokes on those ends. But you just want to make sure that you're zoomed in as much as you can, that you're placing the point in the center of the stop bar that you want to draw from and keeping it close in the center kind of as you go. And then if you notice any particular errors that you've made or whatnot, you just want to make sure to clean those up as you go. The process isn't any fundamentally different. There's no other fields to be added or particular corrections to be applied. It's just a matter of making sure that when you're drawing in the geometry that you're doing it as close to what's actually there as possible.
Thanks, Kyle. So I'm not sure if this one's already been answered, but the question is if are lines to be defined between the lane markings on the roadway?
Yeah, so you want to try and keep it as close to the center of the lane. If I understand the question, the lines generally go from the start of your lane at the stop bar or at the crosswalk, depending on if it's an ingress or an egress lane. And then you want to trace as close a path you can in parallel to the edge markings of the lane straight down the center.
Yeah, I also want to add to this that we have a new feature request that we are about to start working on, that some users requested having lane width visually displayed on the screen as an option, because they were concerned that once you start specifying those lane nodes and then you put width, those lanes would potentially start overlapping because there is no visual feedback on how wide you specify that lane is. So we will be providing a visual feature that will show you back lane width straight on the map, which would allow to adjust those values and make sure that your map lanes don't really there always will be some overlap because they're not if your lanes are not straight, you're going to start getting some overlaps, even per standard, but it will help to make sure that you are not specifying by accident some width that are not correct.
Thanks. And about that, I also see a question about, like, The question is the same length for both ingress and egress lanes, and also a new question about if it is acceptable to use one lane to represent multiple egress lanes in an approach.
So we generally try to map about at least 1,000 feet away from the stop bar or the edge of the stop bar on the egress side, just to keep everything even. Although I have heard of people, specifically in New York, interleaving map messages by having shorter egress lanes so they don't overlap with the ingress lanes of the next intersection over. So it depends on your use case. It's allowed by the standard to do a lot of different things with how you represent the lanes, but it's going to depend on the needs of your deployment program and the data needed or desired by the applications that you're running. And then to the question about using one lane to represent multiple egress lanes, that it again kind of depends on the application. If you're a connected vehicle application where the exact egress lane isn't so important as where the egress lane is or how the vehicle might be able to travel to get there, then that might make logical sense. But if it's some sort of automated vehicle application or connected automated vehicle application that's going to be consuming this data, where it might need to know that higher resolution information about all of the egress lanes so it can select between them and make sure that there's not a conflict with other vehicles in that lane, then it might not work out in that particular use case. In the case where there's a lot of egress lanes kind of in parallel or even ingress lanes, we're aware of a feature request for a computed lanes feature that's still kind of in evaluation phase, but that would remove some of the effort of creating those lanes, as you'd only have to draw that lane or fill in the data elements for that lane once, and the other lanes could be generated procedurally from that given kind of template, but that's not something that's available at this time.
Thanks, Kyle. So another question here we have is, when the tool identifies lane connection, does it populate the D_lane connection ID data element? This is optional in the map message, but is required for SPaT to indicate pedestrian in the conflicting crosswalk.
I believe it does, but I'm not 100% certain of that. Leonid, do you know for a fact on that question?
I can't remember off the top of my head if that is. I don't believe that lane connection ID is populated automatically, but when you go into the SPaT portion, when you can configure connecting lanes, that's where you put your connecting lanes along with the maneuvers that are allowed for that lane. Not sure if that answers your question or not. But that's...
Okay. Sorry.
Okay.
Okay.
I have one more comment to one other question about the zoom levels. So the zoom levels also depend a little bit on the tile. So we are not calculating or scaling ourselves. We allow the Bing API to do that for us. And I believe that zoom level 19 is what you normally see, although but then they create 20 and 21 for you as well. But we've seen some cases when some tile may actually have that 20 and 21 available. So it kind of varies depending on the area. That's all.
Thank you. So I'll ask one last question because we are almost out of time. The last question I see here is, when creating a map, should the user model usable shoulders as a lane when right turn on red is permissible but not recognized as a lane? I don't know if
yeah, so that's certainly an option. I think with the scope of the map tool, that the map tool is just kind of letting you define whatever message you want to define, depending on the use of your the particular need of your deployment. So that should be supported by the map tool from that perspective. But from a recommendations perspective, I think that would kind of bear on the output of there's an SAE J2945/10 committee that's putting together a set of recommended best practices for SPaT and map usage together. And that would probably have some significant bearing on that sort of thing, because that's certainly one way to model that, but you could take alternative approaches that might have different trade-offs.
Great, thank you very much. I guess that would conclude our Q&A. I just want to remind you one last time about next webinar on May 15th. If you're interested to learn more about backhaul infrastructure, design and installation, and ESRLC licensing, please go ahead and register for this webinar. And like we mentioned earlier, there's another one in June as well. I guess I really want to appreciate the panelists, the people who were in the back scene helping with providing you with this webinar. We had some wonderful information here today shared with us. Like I mentioned in the beginning, this webinar is recorded and will be shared with you along with the slides that were shared here today in a post-webinar email follow-up. On behalf of National Operations Center of Excellence and our presenters, I want to thank you and wish you a great rest of your day. Thank you.